time, an ever-present yet elusive dimension of our existence. It's a constant companion, marking our journey from cradle to grave. But what is time really? Is it merely a human construct, a way for us to make sense of the world around us? Or is it a fundamental aspect of the universe, as real as space and matter? Throughout history, we've sought to measure time, to pin it down. From the primitive sundials of ancient civilizations to the sophisticated atomic clocks of today that even account for the universal coordinated time. We've come a long way in our understanding of this mysterious entity, yet time remains a riddle, a paradox. It's always moving forward, relentlessly, unstoppably. But what if we could change that? What if we could control time, bend it to our will, even travel through it? Time as we know it governs our reality, but what if we could manipulate it? The idea of time travel has fascinated us, often seen in the realms of science fiction. It's a concept that has sparked our imagination with stories filled with mind-bending paradoxes, alternate realities, and glimpses into the future or the past. Think of H.G. Wells' The Time Machine, where a Victorian scientist zaps himself into the distant future. Or Doctor Who, where a quirky alien with a penchant for bow ties travels through time in a blue police box. Then there's Back to the Future, where a teenager and eccentric scientist navigate through time in a DeLorean. And let's not forget Star Trek, where the crew of the Enterprise often find themselves dealing with temporal anomalies and time loops. Each of these stories presents time travel in unique ways, exploring the potential consequences and opportunities that come with it. But they all share one thing in common: they ignite our curiosity. While science fiction paints vivid pictures of time travel, what does science have to say? In the vast cosmos exist phenomena that challenge our understanding of time. Among these enigmas are wormholes and black holes, cosmic entities that could potentially pave the way for time travel. Let's start with wormholes. These are theoretical passages through space-time, predicted by the theory of general relativity. Imagine a piece of paper folded in half. If you could poke a hole from one side to the other, you'd create a shortcut. That's a simplistic way to visualize a wormhole. Theoretically, if we could stabilize a wormhole, we could use it to traverse vast distances in the blink of an eye, effectively traveling through time. Now let's turn our attention to black holes. These are regions of space where gravity is so strong that nothing, not even light, can escape their pull. Due to their extreme gravitational force, black holes distort the fabric of space-time. If you were to orbit a black hole, time would slow down for you relative to someone far away. This is known as time dilation. In essence, you'd be time traveling into the future. So how does this relate to time travel? Well, wormholes and black holes are interconnected. Some physicists suggest that every black hole contains a wormhole at its core. If this is true and we could somehow enter a black hole without being spaghettified, we could potentially pop out somewhere else in space, or even in time. However, the realities of cosmic travel are not as straightforward as science fiction might have us believe. Wormholes, if they exist, would be extremely unstable. The moment anything tries to pass through, the wormhole would collapse. To keep it open, we'd need something called exotic matter, which has negative energy and is still purely theoretical. So, wormholes might be our ticket to the past or the future, but there's a catch. We're still in the realm of theory, yet to bridge the gap between fact and science fiction. One thing's for sure though, the universe is a fascinating place, full of mysteries waiting to be unraveled. Einstein once said, "Put your hand on a hot stove for a minute and it seems like an hour. Sit with a pretty girl for an hour, and it seems like a minute." This humorous observation actually holds profound truth about the nature of time, as revealed in Einstein's theory of relativity. The theory of relativity is one of the foundations of modern physics and has two main components: special relativity and general relativity. Special relativity, proposed by Einstein in 1905, introduced us to the idea that space and time are intertwined into a single entity known as space-time. It also proposed that the speed of light is a constant in all inertial frames of reference. Now this is where things start to get really interesting. Imagine you're on a spaceship traveling close to the speed of light. According to special relativity, someone observing you from Earth would perceive your time to be moving slower in comparison to theirs. This is a phenomenon known as time dilation. It's not that your watch is malfunctioning or that time is being stubborn. No, it's the very fabric of time itself, stretching and warping due to the high speed of your spaceship. The faster you travel, the more pronounced this effect becomes. But don't pack your bags for a light-speed journey just yet. Achieving such speeds with current technology is, to put it mildly, a challenge. Plus, There's the issue of energy requirement and the fact that as you approach the speed of light, your mass, as observed from the stationary frame, would theoretically become infinite. That's a lot of extra weight to carry. So, where does this leave us? Well, Einstein's theory of relativity and the concept of time dilation give us a tantalizing glimpse into the extraordinary and counterintuitive nature of our universe. They suggest that time, as we understand it, is not absolute but relative to the observer. Time, it seems, is not absolute but relative. But does it mean we can travel through it? Imagine going back in time and preventing your own birth. Sounds absurd, doesn't it? But that's just the tip of the proverbial iceberg when it comes to the paradoxes and challenges associated with time travel. Let's dive into some of the most famous time travel paradoxes, starting with the grandfather paradox. This thought experiment poses a hypothetical situation where a time traveler goes back and accidentally causes the death of their own grandfather before the conception of their parent. This would prevent the time traveler's existence, and yet, they've clearly existed to go back in time and cause this chain of events. It's a mind-bending loop that seems to defy logic. Next we have the butterfly effect, a concept from chaos theory that has been appropriated into time travel lore. This theory suggests that even the smallest changes in the past could have far-reaching implications for the future. Imagine, for instance, a time traveler who steps on a butterfly during a prehistoric visit. This seemingly insignificant event might alter the course of evolution, leading to a radically different present. And then there are the challenges. For instance, how do we even begin to construct a vehicle capable of withstanding the physical stresses of moving through time? And if we could build such a machine, how would we navigate it? After all, time isn't like a highway with clear signs and exit ramps. It's an abstract concept, a dimension that we understand only imperfectly. Moreover, there's the issue of causality, the principle that an effect must always follow a cause. Time travel, especially when it involves moving backward in time, seems to violate this fundamental principle. If you can go back and change the past, then the line between cause and effect becomes blurred, creating a web of complexities that is challenging to untangle. With these paradoxes, time travel seems more like a conundrum, but the quest is not over yet. As we'll soon see, the scientific community continues to unlock the mysteries of the universe, and who knows, maybe one day we might just crack the code of time travel. Scientists around the world are grappling with the mysteries of time. Time as we perceive it may not be as straightforward as the ticking hands of a clock. With each tick and tock, the scientific community is tirelessly working to unravel the enigmatic threads of time travel. Theoretical physicists with their equations and formulas are exploring the realm of the seemingly impossible. Their research often leads them to the edges of our current understanding, where time and space weave into the intricate tapestry of the universe. The concept of wormholes, for instance, is one such thread being tugged at. These hypothetical shortcuts through space-time could, in theory, enable time travel. Yet, the practicality of such a venture remains a daunting challenge. The energy and technology required to stabilize a wormhole, if they do exist, are beyond our current capabilities. But that does not deter the scientific pursuit. For science, every dead end is a new beginning, every impossibility a challenge to overcome. In parallel, researchers are probing into the mysteries of quantum physics, a field where time seems to lose its one-way directionality. Quantum entanglement and superposition, phenomena that baffle even the brightest minds, hint at potential pathways to the past or future. Moreover, the burgeoning field of quantum computing is adding another dimension to this pursuit. Could we one day harness the power of quantum computers to simulate time travel scenarios? It's a question that is beginning to stir the scientific pot. And let's not forget the cosmologists, gazing into the far reaches of the universe, observing phenomena that challenge our understanding of time. From black holes where time appears to stand still, to the cosmic microwave background radiation that provides a glimpse into the universe's past. These observations might hold clues to the feasibility of time travel. As we delve deeper into the fabric of reality, the lines between fact and fiction blur. Time travel, once the domain of science fiction, is now a legitimate scientific inquiry. And while we may not be packing for a trip to the past or future just yet, the pursuit of that possibility is a journey in itself. A journey that continues to shape our understanding of the universe. Time travel, once a fantasy, might not be entirely fictional. As we've journeyed through the intriguing world of time, we've seen how it has evolved from an abstract concept to a tantalizing subject of scientific exploration. the current scientific consensus doesn't outright dismiss the possibility of time travel. Theoretical physics has opened doors to fascinating concepts such as wormholes, black holes, and time dilation. These concepts, while still largely theoretical, suggest that time may not be as linear as we once imagined. However, it's important to remember that these theories are currently beyond the realm of practical experimentation. The technological and energy requirements to manipulate space-time or sustain a wormhole, for instance, are simply staggering. Moreover, the paradoxes associated with time travel, such as the infamous grandfather paradox or the butterfly effect, present significant conceptual challenges. But science, as we know, is the relentless pursuit of knowledge, and what we deem impossible today might become achievable tomorrow. Just as quantum physics has reshaped our understanding of the microcosmic world, our comprehension of time and its potential manipulability may also undergo revolutionary changes. One such revolutionary concept is the theory of alternate realities or the multiverse. This theory proposes that there may be an infinite number of parallel universes, each representing a different possible timeline. In this context, time travel might not involve jumping back and forth along a single timeline, but rather moving between these alternate realities. This idea, while still speculative, has become a popular topic of discussion in both scientific circles and popular culture. It represents another way that our perception of time may continue to evolve and expand, adding another layer to the enigma that is time travel. The mystery of time travel remains, challenging us to question, explore, and imagine the possibilities of our universe. Whether it's a fact or fiction, only time will tell. But one thing is certain, the journey of understanding time continues to be as mesmerizing as the concept itself.